how to distinguish between the univariate, normality, bivariate, and then the linearity. And it's all just like in kind of semantics. They're very closely related to one another. So we can go over that. So I guess we can just go through the homework. So it was talking about satisfaction and happiness in marriages, and it had asked you to look between men and women, I guess. Okay, so I don't know if you can go back to the original email, or should I send it back to you, or... Okay. We can go through it. I just sent it to you. Okay, so if you open up the data, we can just like quickly walk through how to do the normality and then talk about the differences in the assumptions.
Like how the email response for the auto reply is I'm so proud of you.
Wait, what?
They have like autofill emails
Oh.
that you can send back.
I'm so proud. That's great. I like that. Okay, why don't we turn on the start by the split file just to review how to do that. So go to data and then split file. What, and was it this one where it was pretty obvious that there's differences, or is that the last week? I think that was like from the example that like sometimes the overall group is different than the separated out, which makes sense.
This one, yeah.
Yeah, okay. So yeah, and you can do compare groups or organize by groups at comparing them. So just do that. So then our split file will be on when we do whatever we want to do next. So
When I did a compare groups, it didn't like allow me to. Oh, wait, never mind.
Okay. Okay, so then let's just to do the univariate normality. That's the stuff that we've done a lot, but descriptive is statistics, and then explore, and then we can put in I guess we would do it by both variables to the dependent list, plots, just a histogram, and then normality plots with tests. And that's all we should need. And so this will be our univariate normality. So that's going to look at the normality of the distribution of each dV that we have. And we know how to do this. It's the measures of central tendency, the skewness, kurtosis, histograms, KS test. Am I missing anything? So that stuff. And I actually found some really good articles that kind of break down the like differences in the normality assumptions, which, I mean, we don't have time to read articles, but they have really good graphs to show like the differences, so I'll send that to you guys. Okay, so to do the bivariate normality, we're going to use a scatter plot. So you're going to go to graphs, legacy dialogues, and then scatter dot. And then simple scatter, you can kind of mess with these other ones if you'd like, but the simple scatter is what we'll use. And then remember which one you're going to put on the y-axis and the x-axis. I'm going to put happiness down there. And then you shouldn't have to put anything else. Unless you want to make like a fancy, make it look good, you can put titles and stuff, but we don't really need that. Okay. So, as you can see, it's still this split file still in, so it separated out into female and male, and they're very different. Okay, so if we're looking in the packet, you can figure out, it's kind of confusing. You can use the scatter plot, this scatter plot, for the bivariate normality and linearity. And then you can use the residual plot that we'll do in a second for the linearity and the homoscedasticity. So there's like a little bit of overlap there, and it can get kind of confusing. So I think linearity is a lot more simple to understand. It's just saying, is there a linear relationship between these two variables? Oh, I found it. Oh yeah, on Dr. Menon's slides, like she has a really good example of what, since we're using correlation for right now, she has good examples of what the graphs would look like. Maybe? Okay, so let's just focus on the female for right now. So you can see it does follow a linear line right there. But for bivariate normality, what we're looking for is if the, I don't think they go into really that much depth in our classes, the curriculum, but basically it's kind of combining the distributions of these two different variables to see if it's normal, which is like very otherworldly to me. And the like the actual plotting of this is actually like a 3D like distribution thing, and they just apply it to the scatter plots. And so we don't really need to know all of that for our purposes, but basically to meet bivariate normality, it kind of has to resemble like an ellipsis or ellipses, kind of like you can see that it's like grouped kind of in a certain way all over here. There's a really good example. I don't know if it was on Dr. Menon's slides, but this is kind of not as much grouped. But one of the examples from the articles that I found was of like the assumption being violated was that there was like a cluster here, a cluster here, and a cluster here. So all it's kind of saying is like, does it kind of fit in the same, like starting here, does it kind of go like that out instead of having different groups like everywhere and about? Does that make sense? Right. And so that's how you do the bivariate normality, and then also the linearity. And so when we do the correlation and regression, we'll look at the, we add the residual plots. And I think you helped me, what we figured out, was that you? The Z-pred? Or was that Cherry? I think that was Cherry.
Yeah, maybe. I'd be surprised if that was me.
Okay, so why don't we run,
Is this what you were talking about?
yes, yeah.
Oh, yeah. I don't know if anyone can see this. I don't know how big I can make this.
Yeah.
I think there was another one showing like the actual like funnel shapes and like.
I think that's regression. I think that was in her
Yeah, I think it's like, it's really weird because it all kind of is similar,
Yeah.
doing similar things. So why don't we, for the linearity, let's just run the regression so you can get the plot really quick and look at it.
Are we still keeping the file split?
Oh, good point. Does the question
It says
ask you to keep it?
I had split my file first, and
Mhm.
then did it, and then unsplit it, and then did it again.
Okay.
Go back to the thing and you
Yeah.
just click it again. Check it.
Yeah. I think the correlation was asking separately for males and for females. And then I think for the regression they wanted you to do it as one. Yeah. So why don't we run the correlation? Hi. Okay, so we're gonna look at the residual plot actually first. So go to regression. This is kind of counterintuitive because we're running regression anyway. But so go to analyze regression, and then linear. And so I think I said IV as the happiness, and then DV as marital satisfaction. Oh wait, yes, that's what we're doing. And then so for the plots, you're gonna put the Z pred for the X, and so that's the predicted value of a distribution, and then the Z resid is the residual of that. Ooh, let's do the histogram too. That'd be fun. Okay, so that's how you get this regression residual plot, and that's how we're going to look at the linearity and the homoscedasticity. Okay, so let's just do that. Okay, so at the bottom you can see the regression standardized predicted value, and it's the Y is the standardized residual. So for linearity, it's yeah, okay, sorry. So both of these, you can see that there's not a curved like line. So if there's like in the distribution for the residual plot, if it's kind of curved in a weird way, that's gonna say that the linearity is not being met. It seems a little, I think it's just easier to look at the linearity in terms of the scatter plot versus this residual, but that's just me. Does that make sense, kind of?
We're looking at homoscedasticity and linearity.
Yeah, like the differences between them. So then for the homoscedasticity, we're going to look at the relation of the plot points to one another and if it's kind of even. So this is pretty okay across as you go from horizontally, and this one is pretty okay as well. This is the one where if these these values are really close to one another and clustered, whereas it spreads out a lot more over here, that would be a violation of the assumption. Whereas, I mean, it's okay. It's subjective, but I think it's okay. Does that kind of clear it up a little bit, the differences between them? A little? Yeah. Okay.
Yeah, like the bottom one could definitely be like argued, right?
This one? The male? Yeah, definitely. I think so too. It's kind of wider in the middle and then like out a little bit more clustered. Okay, so let's take a step back and just do the correlation for the two and like look at them, what we have. So go to analyze, correlate, and then bivariate, and then just put two variables in there, and our split file should still be on, so it should just do what we want it to. And then these were the other non-parametric tests, but we're going to use Pearson for right now. Cool. Correlations are so clean and easy.
Sorry, this is probably super obvious, but why are we doing bivariate instead of...
Yeah, so what were the other options? Partial. So these are different types of analyses. So partial correlations are taking in other, yeah, so it's just other ways of running it, basically. I don't know what this distance is, to be honest. But, yeah. And so bivariate just means we have two variables that we're looking at. So when we get into, like, I think sometimes they call it bivariate I guess like linear regression, we go to multiple regression, so that means that we have more than two variables. Does that make sense?
Mhm.
Yeah. Okay, so looking at our correlation, what do we see here based on females and males?
Females are significant.
Yes. And so what does that mean based on like the question that we're looking at? If we were going to put it into like real world
In
terms.
the population.
Yeah. What about it?
Oh, that was my contribution.
So, okay, what we would say from that is let's report the results. Oh wait, I'm looking at regression already. Oh wait. Oh yeah, so we would report the R, Pearson's R, and the p-value for each of the groups separately because that's what we're looking at for this question. We would say whether we reject or retain the null hypothesis, which one is significant and which one isn't. And then putting this into real world terms, we would say that for males, there was not a significant correlation between happiness and marital satisfaction, whereas for females, there was a significant correlation. And because our Pearson R is 0.976, that is a very large positive relationship with one another. So as marital satisfaction goes up, happiness is going up as well, basically.
Is there a certain way that you're supposed to list that, the R and the P, and like, is there a formula?
Like when reporting it.
Mm-hmm. Yeah, I think in the packet, I don't like the packets are really inconsistent because some of them do it really well and some of them are kind of like, just do it this way. But basically, you're just going to do R equals 0.97 or 98.
Is it a big R or a little R?
Little.
And is it italicized or not? It is italicized.
Everything that's not Greek is italicized.
Yeah, and then the p-value, you can put the exact value or just less than 0.01 or 0.05, whatever you're going to use. And so also when we have a significant correlation, we're going to want to do kind of the importance of the statistic. I think that's how they word it in like the PEs and stuff, but it's going to be the shared variance between the variables. So this is where we multiply, we square the R to get that variance. So we're going to take 0.97 times itself, which is something. So 0.96. So that's quite a lot. So we would say that 96% of the variance in marital satisfaction is associated with X. So that's the thing where we have like the two, the Venn diagram where it's like the X circle and then the Y circle. So the middle part is that shared variance.
How would you write that again?
Yeah, so you would, you don't necessarily have to write out like the decimal version. You can just say that in the population, 96% of the variance in marital satisfaction is associated with happiness. Does that make sense?
That's the shared variance.
Yes.
That was the square root of 0.97.
It's square, not square root. Yeah.
So it's the variance accounted for or not accounted for?
That's kind of a different context because we're talking about like correlation, so like associating how much are these two variables related.
So it's not about variance.
It is about variance, but what accounted for is more with like regression and prediction, whereas correlation is just kind of like how do they relate to one another.
Okay, so say it again, how you would say it?
Yeah, so you would say 96% of the variance in marital satisfaction is shared or associated with or related to happiness, or vice versa, because it's a correlation, it's a two-way street basically. Not one, not one of them goes first. Do you know what I mean? Yeah. Cool. Does that make sense? Okay. So then we can turn off the split file, data, split file, and then just put them back.
Or you can hit reset.
Oh, nice. Cool. So it's off, so we can, again, run the regression that we already did. So regression linear, and then so which one is our IV or which one is our DV? Happiness is IV. Okay, cool. So I have that in there. And we already did the plots, so they should be ready for us. And we shouldn't have to change anything else. So another thing is, so with regression, we're trying to predict scores in one variable based on another. So that is why the IV and DV does matter. We have to know which one we're looking at.
And that's the main difference between regression and correlation.
Mhm.
Correlation is just a relationship.
Mm-hmm.
Regression is prediction.
Yeah, definitely. And then a nice thing, so we can go ahead and run it. A nice thing about regression is that it also does the correlation. It gives us a correlation in itself, just to say how related the two variables are in general, and then we can look at how they may or may not predict. The IV might predict the DV.
What does it give a correlation?
In model summary. So this is our Pearson
Oh, I
R, and then R squared. So that's our shared variance. And then adjusted R squared is just like it sounds. It's adjusting, trying to account for some of the error in the population, in the distribution, that type of thing. So when we are reporting the results of our regression, we're gonna want to put the R squared, and the adjusted R squared to kind of show how the variables are related to one another, and then the p-value as well.
Am I making a mistake here? I think we have it backwards.
Yes.
Prompt says conduct linear regression in which the dependent variable is happiness. Is that not? Did you notice do the opposite?
Yes, we did the opposite. So let's switch that around. Good catch. So I think, okay, yeah, the scatter plot should be the same. Let's look at that again. Cool. And you'll notice that the model summary didn't change at all because we just switched around the IV and the DV, but for correlation, it doesn't matter. Yeah. So again, the R is the Pearson correlation between the two variables. The R squared is the proportion of variance that is shared between the two variables. And then adjusted R squared is just kind of correcting in the population what it might look like.
And the adjusted is with the little hat on it. Is that the deal?
Yes. No? With Dr. Menon stuff?
Y hat is the predicted value of y based on the regression equation. So, like you have an x and y value. So when you put the hat over y, it's the value that results from the regression equation, which has the coefficient, the beta, all those pieces.
So adjusted R is just adjusted R.
Mm-hmm. Yeah. So, yep, and then do we reject or fail to reject the null? What is the significant result, and how do we apply the R squared and R squared adjusted between the variables? So we would say
So we reject the null.
Mhm. So what does this mean for the question that we're looking at?
Overall, in the population.
Yeah, so in the population, how did I put it?
Happiness predicts marital satisfaction, or the opposite. Marital
The opposite way.
satisfaction
Yeah.
predicts happiness. For males and females combined, but not separately.
And then looking at the R squared and adjusted R squared, so for R squared, that is telling us the percent of variance shared in the sample, whereas the adjusted R squared is looking towards the population. So that's why there's like a little bit of a correction on it, because the R squared is just like within our parameters, our sample, what's going on with us. So that's an important distinction between the two. And then for our regression equations, what does that look like? Anybody? So we have our non-standardized equation and then our standardized equation. Okay, so and standardized. So this would be the y hat. Is it predicted? And then
A plus 3.
so where on in our output would we find the A and the B?
A is the constant.
So it'd be this guy right here.
Yeah, when x equals 0.
And then what would our
It's the R slope regression coefficient. The B, is that what you're talking about? Yeah, the regression coefficient.
so it would be this one because it's unstandardized. So that's what our non-standardized regression equation would look like. And then for standardized, we only have one value that we're putting in here, and where would we find that? So 0.54. Does that make sense?
So there's two pieces of code here. Even though it didn't ask for both equations, you have both equations. And even though there was no mention in the prompt of hypotheses at all, it wants to address the hypothesis.
Yeah. Yes.
I'm sorry, can you explain the standardized thing again? I don't understand.
Yeah, so also going back, I will try to make the PE have better prompts because I understand that like it doesn't always ask for it, but this is like the curriculum that I was given. So anyway, so for non-standardized, so like you have like a graph, a plot here. So
Well, I get the non-standardized, but
yeah.
what's the difference? Oh, the standardized has a 0.
Yeah. So like non-standardized would like be there or wherever, whereas standardized is going to go through the middle, so you can compare it to other standardized. Yeah.
What is the actual equation for the standardized? Like,
So
with variables instead of numbers? Like, what would the 0.54 be represented as a variable?
oh, it's the is it B? Yeah.
Okay.
Oh, it's no, it's R. Because this is also, okay, so when we get into multiple regression, it'll be something different, but because, I don't know if you remember, because this is just linear regression, we're just using the two variables, our slope is the Pearson correlation. Whereas when we get into multiple regression, it's going to be a little bit different because we have different variables and that type of thing.
So the R that we're using is the Pearson's correlation? Yeah. Can you go back to say where it is?
So right here. And if you scroll up, you can see that they're the same. So when we go to multiple regression next, we'll have more variables in our coefficient table, and so it'll be it'll be different. We'll do different things. Any questions? Let me. So for the PE, I just looked. So we're going to have one data set. It's going to be pretty similar. And it's going to ask you about the assumptions and like your rationale behind them for both the correlation and regression because they have the same assumptions and we're looking at the same data. And then it's going to ask you to do a correlation for the full sample, correlation for the sample split up, and then a regression for the full sample. And then if you'll remember, we're gonna meet next week on Wednesday. Kind of probably how we did it like last semester. Like I get out of my thing at 3:50, and I think you guys have class until 4. And so once we get all settled, we can like settle down and then just start whenever everyone's here. That works.
So the P is next week?
Yeah. So,
You don't want to answer this, but is that question, the last question on the homework, is that repeated? The one about why the p-value was the same for regression correlation?
is it on the PE?
You probably don't want to answer that. Well, what I just
No.
It's not.
It's not.
I just wasn't sure because I answered it, and I think I answered it correctly, but it felt complicated. Is there a simple answer to it? Is it just that they're the same, essentially?
Yeah.
Without directionality?
Yeah.
Okay.
Basically. Good point. And it doesn't ask you for the equations on the PE, but I'll have that be extra credit if you guys, I'll add that to the end. If you give me both equations, that can be extra credit for the PE. So as long as you know where to look, you can just plug them in. It's pretty easy.
For the assessments at the end, so it's all multiple choice, right? But will there be questions like, what does a small r italicized represent?
Not really, because that's like notation kind of questions is more about the theory.
Okay.
Like it won't just ask you like what does this like lettered variable stand for.
Okay.
More like what is the Pearson correlation? What is that about? Like stuff like that. Yeah. Okay. Any questions? Cool. I mean, we're done then for today.